Hey everybody, this is Mr. Beckstrom, and this video is just kind of a response to a forum post question about this problem from section 10.2 on the parabola, and I just kind of wanted to go through my thought process on how I would solve something like this, especially if it were, let's just say asked on the test. Alright, so I'm going to first copy over the table. This is from page 659 in the text, and it gives me the list of the four equations that I'll use for a parabola depending on a few different factors. So notice in these top two, the y is getting squared, and when the y is getting squared like this, that means it's opening left or right. Now, depending upon what the sign of this term outside the parentheses here is. If it is a positive, that means it opens right, and if it's a negative, that opens left. Now, if the x is squared, that is kind of like your normal equation. When you think of a parabola like y is equal to x squared, that's one that either opens up if it's positive, or it opens down if it's a negative. And same kind of thing here. So since the y is by itself and the x is being squared, these are like your typical parabolas that hopefully you've seen before. So if this is positive, it opens up, and if this is negative, it opens down. So once we get it into a form that looks like one of these, then what we can do is we can set the 4a or the negative 4a equal to the constant that we have on the outside of the parentheses there to solve for a, and kind of go from there. All right, so let's go ahead and do this. So as we can see, we have a y being squared out here. This kind of lets us know this thing opens left or right. And this value out here is positive, which means it's going to open to the right. So here's the equation that we're going to use right there. So let me go ahead and write this down. So this is y minus k, quantity squared, is equal to 4a, x minus h, x minus h. All right, so let's go ahead and start solving for these things. They give us really nice, easy way to find the vertex, the focus, and the directrix. So we'll just use those right along there. Now the vertex is hk. The h is over here, the k is over here, but notice that the formula has a minus in front, so that tells me I have to take the opposite sign of whatever's up here. So whenever I have a minus in the formula, I just got to take the opposite sign. So I have a positive 1 here, so that means my h is going to be a negative 1. So the vertex is negative 1, and the sign here is a minus 2, so that means the k, or the y value of my vertex, is going to be a positive 2. So this here is my vertex. All right, and then let's do the focus next. So in order to do the focus, not only do we need h and k, but we also need to solve for a. Well, I know that this thing here is equal to this thing here because we've matched up everything else. So I'm just going to set an equation for that. So 4a is equal to 8, and therefore a is equal to 2. All right. So once again, if we have a positive out here, we're going to match it up to one of the ones with a positive in front of the 4a. Okay. All right, so now that I know my a, and that's 2, my focus, just using the formula there, and let me go ahead and write h and k down there just so I don't get confused. H is equal to negative 1, and k is equal to 2. So my focus here is h plus a, so that is negative 1 plus 2, which is 1. And my second value in the focus is just k, which we already know is 2. So that's my focus. And let's now look at our directrix. That is the vertical or horizontal line that's kind of not touching the parabola. It's on the back side of the parabola. So if you think of the focus being in the bowl of the parabola, the directrix is the line that is on the other side of the vertex. So directrix, excuse my horrible writing on this whiteboard, but that's going to be a little arrow thing there. X is equal to h minus a. So x is equal to h is -1, a is 2, so -1 minus 2 is -3. -3, so that is my directrix. We already have our equation. The only thing we really have left to do is to graph this. So let's get some room here. And I'll draw a little makeshift graph here. So we know the vertex is at -1, 2. So go -1 and then +2, and it's going to be right here. We know that this thing opens to the right. So without really finding the x and y intercepts, which I could do, I don't think it was asked to do it in this one. Let me just go up here. If I want to see where this thing crosses the y-axis and the x-axis, I can just go back to the original equation up here. To find the x-intercepts, I just put in a 0 for y, and then I solve for x. And to solve for the y-intercepts, I put a 0 in here for x, and then I solve for y. I think this would be a good exercise to kind of do in this here. So let's take a look at, we'll find the y-intercepts for this. I'll let you find the x-intercepts on your own here. So to find the y-intercepts, let me give myself a little bit more room, but we're going to let x equal 0. So y minus 2 quantity squared is equal to 8. And we said we're going to let x equal 0, so 0 plus 1. And now I give myself some more room. And then we're going to end up solving for y. And that's going to end up giving us the y-intercepts. Now, since this thing opens up to the right, I'm expecting there to be 2 of them. So let's go ahead and FOIL this thing out. So that's going to be y squared minus 4y plus 4. This is just y minus 2 times y minus 2. You're going to get a -2y and a -2y. That's where I get the -4y from. Is equal to 8 times 1, which is 8. So y squared minus 4y. Subtract 8 from both sides here. I'm going to get -4 is equal to 0. Now, as you notice here, there is no way to factor this, because the only factors of -4 would be +2 and -2, which is not going to give us that here, or +4 and -1, which does not add together to give us a -4, or -4 and +1, same thing. So since this is unfactorable by normal means, I have to use the good old quadratic formula, which is -b. So -b plus or minus the square root of b squared minus 4ac all over 2a. So this is what we're going to use to solve that. All right, and I'm going to go ahead and write down my a, b, and c over here. So a is equal to 1, b is equal to -4, and c is also equal to -4. So this is going to be a negative of a -4, so that's going to be a +4 plus or minus the square root. B squared is 16 minus 4 times a times c. So 4 times a times c, that's going to be, a times c is -4, so -4 times -4 is +16. And all over 2 times a, which is just 2. So we can go ahead and reduce this a little bit. So this is going to be 4 plus or minus the square root of 32. all over 2. And keep going because I can write 32 as 2 times 16, and 16 is a perfect square. So this is 4 plus or minus, the square root of 16 is 4, so this becomes 4 root 2 all over 2. And lastly, I can divide each term by 2, so this is just going to give me 2 plus or minus 2 root 2. And those are my 2 solutions for this. So I know it kind of stinks here, but we can at least get a decimal approximation here by pulling up our calculator and saying, hey, what's 2 plus 2 root 2? And that gives us a little less than 5. And I can also do 2 minus 2 root 2. And that gives us almost negative 1. So it's going to go through almost 5 and almost negative 1 on the y-axis. So it's going to come down here. Oh, wow, that was kind of weird. All right, well, we'll take it. Let's try again here. All right, so we're going to come down here, and it's going to go through like negative 1, and then that 1, 2, 3, 4, 5, and it's going to come up here as well. It's going to kind of look something like this right there. And we could find the x-intercept, but like I said, I'll let you do that. But this is everything. Really what you're wanting to do is first make sure it's in this kind of form here. A lot of times we have to complete the square if it's not in this form, and I've done some videos on that. And then you just match it up to these equations here. And then you just use those formulas to find the different things. And the directrix we said was x is equal to negative 3. So let's go ahead and put that into. So that's just a line over here on the outside of the parabola, and then the focus was 1, 2. So 1, it's going to be like right here. And the focus and the directrix give us our formal definition of a parabola. They don't really help us graph it when we're doing it by hand, unless you're actually using some kind of like rulers or something. But if you take any point and you look at this distance here to the directrix and this distance here to the foci, or the focus in this case, these distances will be the same, and that's how we define a parabola. All right, guys, I know it's a lot of stuff, but like I said, important part is getting in one of these forms and being able to identify your H, your K, and your A. If you have any questions, let me know, and I hope you have a great rest of your week and good luck on the test.